Okay, I'm going to write down a pure theoretical model that we could have that's similar to the kinds of problems we deal with in regression. So what we're going to say is that we have at the moment we have two random variables, and that there is some kind of relationship between the two of them, that y is shifted and rescaled version of x. So we need to shift the center somewhat and rescale x so that given x we know y, but we're going to then say this isn't done perfectly. There's some kind of error or disturbance which we're also going to describe by being an unobservable random variable. Now, depending on your statistical framework, these terms here can be various things, but for now we'll just assume that these are unknown constants. So we have y and x and epsilon are all random variables. We have, for now, beta 1 and beta 2 are unknown constants. And we'll say one thing further: we will assume that the expected value of the error or disturbance terms given x is equal to 0. So there's no knowing anything about x tells us nothing about the error terms. Now if we set that up as our basic mathematical statistical model, let's just have a look at a couple of properties of this model. We basically said that y equals y, although we didn't quite write y. Instead we wrote beta 1 plus beta 2 x plus epsilon. But y equals y, so we can say the covariance of x and y is equal to the covariance of x and y. Now we can tidy up the right hand side of this. We have terms that enter in an additive way, so we can break things apart. So we can make this the covariance of x and beta 1, the covariance of x and beta 1x, and the covariance of x and epsilon. Now, very simply, without any trouble at all, covariance of a random variable with a constant is 0, so we can remove this, and because of our assumptions, this collapses to the expectation of ex, and again because of our assumptions this collapses also to 0, so we can remove that term from our model. So what we're left with is simply the statement that the covariance of x and y is equal to beta 2 is the covariance of x and beta 2x. Because this is a covariance, this beta 2 term is in there once and comes simply out of the brackets, which leaves us with the covariance of x and x. So we can simplify that to being beta 2 multiplied by the covariance of x and x, which we usually call the variance. So if we tidy that up, what we end up saying is that the covariance of x, y is given by beta 2 multiplied by the variance of x. Now, we can make beta 2 the subject of this, so beta 2 is equal to the covariance of x and y divided by the variance of x. And the point to note here is, again, this is a theoretical model which has two random variables, an unobservable random variable such that the expectation of this unobservable random variable is 0, and we have two unknown constants. And based on that problem statement and the assumption we've set out here, we can derive properties such as the relationship between the covariance of x, y and the variance of x, which tells us something about beta 2. At the moment, there's not a lot we can do with that because this is just a theoretical statement, but we will find as we go through the course we're going to carry out various data handling procedures, and depending on the assumptions we make when we're doing that, we can claim what we're doing has analogies to some kind of theoretical model like this one. So the key thing we have to watch when we're doing that is to look very closely at the assumptions we're making. And in this case, note carefully the problem: a random variable and a random variable on both sides, an error term, an unobservable random variable, and an assumption on the errors.